Okay, welcome back. And in the previous video, we broke down the graph of sine. So we unwrapped this unit circle. We just went along this unit circle and got our graph of sine, which is a periodic function, okay? Now we're going to pick up right where we left off. All right, so we graphed this function here. We graphed y equals sine of x. That is the parent function for sine, and that's exactly what we graphed. And we talked about how it was a periodic function and how it has an amplitude, a midline, and a period. But I said that we can change these, and now we're going to dive into how those values change. We're going to focus on one at a time, though. So we graphed just y equals sine of x. These are the values that are going to affect the amplitude and period, okay? We'll get to midline in a future video, but I want to break down these two first. All right. Now, if I think about what my function was, that function was just y equals sine of x. Apologize for the terrible y right here. That's going to drive me crazy. So we just graphed y equals sine of x. Okay. Well, think of what the amplitude was. The amplitude was 1. That's because there was kind of an imaginary 1 out here, okay? So the amplitude is actually going to be the absolute value of whatever this number here is, a, okay? The absolute value of a is going to determine the amplitude. Notice I'm saying the absolute value. If it was like a negative 1, the amplitude would still be 1. That negative, remember, just means it's reflected over the x-axis, and we'll talk about that in a second as well. So that is our amplitude, 1, absolute value of a. Period is a little bit weirder. Okay, the period was 2 pi, and that's because this b value here was also 1. Because to get the period, we do 2 pi over the absolute value of b. Notice I'm saying the absolute value of b once again. If b is negative, that just means it's reflected over the y-axis, but I'm not really going to dive into those all that much, okay? Just know that's what happens. So the period is 2 pi over the absolute value of b. So that's why it took a horizontal length of 2 pi to complete one full cycle, one full pattern, okay? Now I wrote x scale, right? I wrote x scale for a reason. We only plotted the points that resided on the x and y axis. The points that divide the 4 quadrants, okay? Now, the length of the cycle, period, was 2 pi, and notice we went by pi over 2. Well, that's just 2 pi divided by 4. We went by 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay? And that's how we figure out what the scale for x is. We take the period and we divide it by 4. Okay? And that sounds confusing right now, but promise you, I'm going to clear that up. All right? So I want to jump right into an example. So let's say I wanted to graph something like this. Y equals, let's say, 2 times sine of x. Okay, now not much is going to change from this graph and the parent function's graph. The only thing that really changes is the amplitude. Since we changed this value of a, notice it used to be 1, now it's 2. That just means that the amplitude is going to be 2. That just means that we're going to travel 2 above and 2 below the midline. Okay, so the amplitude is 2. The period is 2 pi over b. Well, notice there's no number attached to the x. That's what the b value is. So b is just 1 once again. So the period would be 2 pi over 1, which is 2 pi. Okay. Now, x scale. What we do is we take whatever the period is. The period was 2 pi. Okay. And I just divide it by 4. And that gets me pi over 2. The reason we do that is so we have those nice points. I only plotted when y was 0, 1, or negative 1. I didn't want to plot it when it was 1/2 or root 3 over 2 or negative root 3 over 2 or negative root 2 over 2. Okay, so that's why we do that. You can plot all those points. Have fun. It's going to be terrible. Okay, so now we're going to go ahead and graph this. And this information actually helps us figure out exactly what our graph should end up looking like, because we have to actually figure out what the scale is. Well, I figured out what the x scale is. That's pi over 2, so I'm going to go by pi over 2. So 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, which reduces down to 1 pi. I'll leave it as unsimplified fraction for now. That would be 2 pi over 2. Then I would add another 2 pi, or pi over 2 to get 3 pi over 2. And then I would add another pi over 2 to get 4 pi over 2. Okay, and now you can maybe see where some of these values are coming from. This ends up reducing to just pi, and this ends up reducing to just 2 pi. Okay, let me go ahead and get the pen back. So pi and 2 pi. So notice how the period gets us the x scale. That gets us our idea here. The amplitude actually determines, or actually helps us figure out what the y scale would be. Okay, now the midline is still going to be y equals 0 for this video, and probably the next video is still going to be y equals 0. I'll alert you when it changes, okay, and I'll show you what changes it. But the midline is still 0 and the amplitude is 2. That means I'm going to be going 2 above the midline and 2 below the midline to hit the maximum and minimum. Okay, and now we graph sine. Now, one thing that you need to notice is that sine started at its midline. Notice how it started at the midline. It started at 0. Okay, that's not going to be the case for all other graphs, but for sine it is. Sine starts at its midline, so I start the pattern at its midline, which is 0. Then sine moved up to its maximum. So that's exactly what I'm going to do. I'm going to move up to my maximum. Then it moved down to our midline again. And then to avoid from scrolling back and forth, and went back down to our minimum, and then back up to our midline. So this is the pattern. It starts at its midline, goes up to its maximum, goes down to its midline, down to its minimum, up to its midline, and that's one full cycle. Okay, and then I can connect this. Make sure you connect it with a nice smooth curve. You don't want it to be all jagged. Okay, and that would be this particular graph. Okay, and we can continue if we wanted to. I can go to the left, negative pi over 2 if I wanted to. And I could just kind of continue to pattern that way. I could go a little bit further and keep going this way. It doesn't necessarily matter. For my purposes, I just kind of want you to graph one full cycle, which is this chunk right here. So notice midline went up to its maximum, down to its minimum, back to its midline. That's one full cycle. Okay, so that's how we graph these. I'll go ahead and take a look at one more with you guys. So let me go ahead and get some space here. Let's say we get something like y equals 3, or let's say negative 3 sine of x. Okay, now pause the video and try this one out. Okay, so hopefully you tried this one out. Now, the amplitude would end up being 3 because it's always the absolute value of a. And the absolute value of negative 3 is 3. Now that's going to tell me that I need to go 3 above and 3 below my midline to hit my maximums and minimums. Okay. Now our period is 2 pi over b, so the b value hasn't changed, so it's still just 2 pi over 1, which is 2 pi. And our scale is still going to be pi over 2, as seen here. Okay, so notice the amplitude helps you get the y scale, and the midline also. We'll cover that in a future video. The amplitude and midline kind of help you figure out the y scale, the y-axis, and the period helps you get the x scale, the x-axis. Okay, now the one thing that I didn't address in the previous example is that negative right here. But I did say, remember, what this means is that it's reflected over the x-axis. So it doesn't change any of these values here. However, what it does change is the pattern. Okay, now sine always starts at its midline, and our midline is 0. So that always is the case. Now normally, sine rises to its maximum. But because it's reflected, It used to go to its maximum, but it reflected over the x-axis, and now it's at its minimum. So when you're reflected over the x-axis, all that changes is basically you don't go up to your maximum right away, you go down to your minimum, and then you just keep the pattern going, okay? So I went down to my minimum. The only way to go from the minimum is up to our midline. Then we go up to our maximum. And once we're at our maximum, the only way to go is down. So we go down to our midline again. And this would end up being the graph of this particular function. This would end up being the graph. Hopefully yours looks better. It's a little bit harder to draw on this computer screen as opposed to paper. So this would end up being our graph, okay? We went down to our minimum first because of that reflection. All right, so practice these skills. Make sure you're able to identify what the amplitude is. In the next video, we're going to be changing the amplitude and the period, so make sure you check that out.